Today we are going to be solving systems by elimination day number 1. Our content objective is students will be able to solve systems of equations by elimination. Our language objective is students will be able to explain how to eliminate a term to solve for a variable. Why am I learning this? Well, it's important for real life problems like how many of each shirt or pants you can purchase with a specific budget. First, we're going to go over some background knowledge. So far, in order to solve a system, we've used graphing methods and we've used algebraic approaches. For the graphing method, what we did was we graphed our two lines, find out where they intersected. That was our solution. This could sometimes be pretty time consuming and it's not always accurate. So we took an algebraic approach, which is basically using the substitution method, where we took an expression, substituted in to solve for a variable. But now we're going to be using the elimination method. So this is just yet another method you can put in your toolbox that you can use to solve systems. So that's what we're going to be working on today. So for our first example here, they gave us a system and they asked us to solve by using the elimination method. So the whole point about the elimination method is you want to get one of the variables to cancel out by adding straight down. So what do I mean by that? Well, here, first what I'm going to do is go ahead and recognize, can I simply add straight down and have one of the variables eliminate? And the answer is yes, I can. And let me show you. I'm just going to go ahead and rewrite this real quick. So I'm going to do 2x plus y equals 6 and 3x minus y equals 4. Notice here, a positive y and a negative y will cancel each other out because they are inverses of each other. So this is going to become 0, leaving me just with 5x equals 10. Simply divide both sides by 5 and you'd be left with x equals 2. So now you have one value of your solution. You need to just figure out what y is, so you get to plug it into either of these equations. I'm just going to choose the first one. So we're going to do 2x plus y equals 6. You're going to substitute 2 in for x, so you're going to have 2 times 2 plus y equals 6. 4 plus y equals 6. Solve for y by subtracting 4. Now I'm left with y equals 2. Now that I have both the x and y values, I can go ahead and write the solution as x goes first, y goes second. And again, I'm going to say that I think the solution is 2 comma 2 because I have yet to check my answer. Let's go ahead and check real quick. If we claim that the solution is 2 comma 2, x's is 2, y's is 2. Let me check real quick. 2x plus y equals 6. I'm going to go ahead and plug in 2 for x, 2 for y. It's supposed to equal 6. So here 2 times 2 is 4, plus 2 equals 6. Is this true? Yes. Now you need to check the other equation, which is your 3x minus y equals 4. I'm going to do 3 times 2 minus another 2 for y equals 4. We have here a 6 minus 2 equals 4. Is this true? Yes, it works for both, so I can confidently say the solution to this system is 2 comma 2. Okay, so now what I would like you to do is go ahead and try this example and see what you get. Okay, so let's see how well you did. So hopefully you still remember that we're trying to eliminate at least one of the variables by adding straight down. Hopefully you notice here that the x's are going to cancel out pretty nicely. So let's just go ahead and rewrite it. X plus 3y equals 5, and then negative x plus y equals 3. Here you can just see that a positive x and negative x are inverses and they're going to cancel each other out, which leaves us with 3y plus 1y essentially is a 4y equals 8. Simply divide both sides by 4 and we're left with y equals 2. Now that we have one part, we're going to go ahead and substitute into one of the others. I'm actually going to use this one here. So I'm going to do negative x plus y equals 3. So here we have a negative x plus a 2 equals 3. Simply subtract 2 from both sides. Negative x equals 1, but you're going to have to divide off that negative 1. And we're left with x equals negative 1. So now that we have both the x and y values, I'm going to go ahead and say that I think the solution is first x goes first, y comes second. And again, I say that I think because I still need to check my work. So real quickly, let's check your work. Quick reminder, x's are negative 1s, y's are 2s. Whoops, got ahead of myself. Let's go back. Let's go ahead and check our work. We have x plus 3y equals 5. For x's, I'm going to put a negative 1. For y's, I'm going to put a 2. So we have negative 1 plus 6 equals 5. This is true. So it works for the first equation. But again, with systems, you want to make sure that it works for both. So we have a negative x plus y equals 3. You're going to plug in a negative 1 for x and a 2 for y. Here we're left with a positive 1 plus 2 equals 3. We end up with 3 equals 3. So guess what? It works for both. So you can confidently say the solution to the system is indeed a negative 1 comma 2. Okay, so I'm going to try another example. Here, same idea. You want one of the variables to cancel out when you're adding straight down. So something you're going to have to keep in mind of is you want to make sure the x's line up, the y's line up, and the constants line up. Right now, the equations are given to you very nicely because they're already lined up, but please understand this is not always going to happen. So I'm just going to go ahead and rewrite it. Negative 3x plus 4y equals 6, and 5x minus 4y equals negative 26. Conveniently, I do have variables that are going to cancel out nicely. And again, you're going to be spoiled today. That's going to happen, but will it always happen? No. So in this case, you're going to notice a positive 4y and a negative 4y. Those are inverses, so they're going to cancel out, leaving you with just 0. So here, you're just going to combine like terms. Negative 3x plus 5x is a positive 2x. Here, we're going to be left with a negative 20. Simply divide both sides by 2, and x equals negative 10. Once again, you're just going to go ahead and take this value and plug it into one of these equations. I'm going to plug it into the first one. So we have negative 3x plus 4y equals 6. I'm going to go ahead and plug it in for x, so I have negative 3 times a negative 10 plus 4y equals 6. Here we have a positive 30 plus 4y equals 6. Let's get rid of this positive 30, leaving us with 4y equals a negative 24. Divide both sides by 4. And we're left with y equals negative 6. So now that we have a value for x, we have a value for y. I'm going to go ahead and say that I think the solution is negative 10, comma negative 6. And you know that I always say I think because we still need to check our work. So let's quickly check our work to see if we have the right answer or not. So, whoops, again, I keep getting ahead of myself. Let's go back. I'm going to go ahead and plug in my values. Negative 10 for x's and negative 6 for y's. I have negative 3x plus 4y equals 6. For my x's, I'm going to plug in a negative 10. And for the y's, I'm going to plug in a negative 6. So here we're going to simplify. Negative 3 times negative 10 is a 30. 4 times negative 6 is a negative 24 equals 6. 30 minus 24 is 6, so it does work for the first one. But again, we have to check both. So we have 5x minus 4y equals negative 26. Here, my x's are negative 10s, and here the y's are negative 6. So here we have a negative 50. This is going to be positive because the negative times negative is a positive. It's going to be plus 24 equals negative 26. Here we have more negatives, and it is negative 26 equals negative 26. So it does work for both, so I can confidently say the solution to this system is indeed negative 10 comma negative 6. So at this point, what I would like you to do is I'm actually going to have you pause the video and try numbers 4 and 5 on your own. Okay, so let's go over the answers for numbers 4 and 5 and see how well you did. For number 4, again, you're trying to find at least one variable where it's going to cancel when you add straight down. And before you do that, again, you want to double check that the x's are lined up, the y's are lined up, and the constants are lined up. It's not always going to happen this way. Here, I'm just going to save myself some time and do it straight here. These are going to cancel, leaving me with 7y equals 0. Please understand it's not the end of the world. If you end up with a 0, just keep going on the way you normally would. Here, you're going to divide both sides by 7. So I can do y equals 0 divided by 7 is 0. So notice here, it's okay if 0 is in the numerator. You can have 0 divided by a number. You just can't have it in the denominator because you can't divide by 0. So now that I know what y is, I'm going to go ahead and plug it into one of these equations. I'm going to go with the second one right here. 2x plus 2y equals 10. So here, I'm plugging in 0 for y. I'm going to get 2x plus 2 times 0 equals 10. And I'm left with 2x equals 10. Simply divide both sides by 2, and I'm left with x equals 5. So now that I know both, I'm going to go ahead and say the solution is, first x goes first, so it's 5 comma 0. But I think this is the solution because I still need to check my work. Okay, so let's go ahead and check the work. In this case, my x's are 5s, my y's are 0. So here I'm going to have negative 2x plus 5y equals negative 10. I'm simply going to go ahead and plug in a 5 for x, which goes here. And for y, I'm going to plug in a 0. So I'm going to be left with negative 10 plus 0 equals negative 10. This is totally true. Now for the next one, 2x plus 2y equals 10. My x's are 5s. My y's are 0s. Is this true? 2 times 5 is 10. 2 times 0 is 0. And it also, it also works for this equation. So I can confidently say the solution to this system is indeed 5 comma 0. Okay, so I also asked you to do number 5, so let's go ahead and check this one. Again, we're trying to get one of the variables to cancel out straight down. Here, what's nice is the x's line up, the y's line up, and so do the constants, including the equal signs. You got to make sure that that happens. Since I notice here the 5s are going to cancel out nicely, I'm just going to go ahead and put a line. These are inverses of each other, so that's going to go away. Now I'm going to be left with more positives, so that's positive 2y equals here. There's more negatives, and there's 4 more. Divide both sides by 2, and I'm left with y equals negative 2. Okay, so now that we have what y is, we're going to go ahead and plug it into one of these. I'm going to go ahead and plug it into the second one. So I have a 5x minus 8y equals 26. I'm going to go ahead and take this value and plug it in for just the y. So I have 5x minus 8 times the quantity, or times negative 2 equals 26. So here I'm left with 5x. This is going to be a positive because a negative times a negative is positive. At this point, I'm just going to get rid of my constant, which leaves me with 5x equals 10. Divide both sides by 5, and my x is 2. So now that I know the value of x and y, I'm going to go ahead and say that I think the solution is, positive 2, because x goes first, comma, -2, y goes second. But again, you always say you think at first because you still need to check your work. So let's go ahead and check the work. The x's are 2, the y's are -2. So here, I'm just going to go ahead and first copy down the equation, -5x plus 10y equals -30. The x's are 2's, the y's are -2, and it's supposed to equal -30. So here, this is going to be -10. This would be a -20. -10 minus 20 is -30. So the first one checks out. Now I need to make sure I check the second one because it's not a solution to a system unless it works for both. For x, I'm going to go ahead and put a 2. For y's, I'm going to put my -2. Here we have 10. Here we have a +16. Does it equal 26? The answer is yes. So guess what? It works for both. So I can confidently say the solution to that system is indeed 2, -2. So hopefully you got those two correct. You checked your work and you're confident that that was the answer. Now I'm going to show you just one more type. So here, I can't reiterate enough to you that the whole point of elimination is you're trying to get at least one of the variables to eliminate or cancel out by adding it straight down. So again, you want to make sure the x's are aligned, the y's are aligned, the equals are aligned, and the constants are aligned. So here, I can't just cross out the y's because a -y is not going to cancel out a -y. So here, for example, if I just added straight down, I would end up with 10x minus 2y equals 30, which is not exactly very helpful. So what I'm going to have to do is I need to make one of the y's positive in order for it to eliminate. So here's what you're going to do. You must change at least one, well, not at least, you must change exactly one of the equations so that your y is a positive. So I'm going to go ahead and change this very first one right here. Because I have to change the entire equation, I'm going to put parentheses around the entire equation. I'm going to go ahead and distribute a -1. Now watch what happens. Now I'm going to be left with a -8x. Now it's going to be a positive y equals, and again, you even have to distribute to the very last term, which makes it a -24. Now that I have a positive y, I'm just going to go ahead and line this underneath it, which is the 2x minus y equals 6. Now you're going to notice that I can't eliminate the y's because they're inverses of each other, leaving me with a -6x equals a -18. Simply divide both sides by your coefficient, and you'll see here your answer is going to be x equals a +3. But of course you're not done. You must plug it into one of these. I'm just going to go ahead and plug it into the second one here. So 2x minus y equals 6. Plugging in this 3 in for the x, I'm going to have 2 times 3 minus y equals 6. Here, this is going to be 6 minus y equals 6. Subtract 6 from both sides, leaving you with -y equals 0. But you're going to divide off that -y, and you're left with just y equals 0. So just a friendly reminder, it's okay if 0 is in the numerator. You can have a number being 0 being divided by a number. You just can't have it the other way around. You cannot divide by 0. So here I'm going to say the solution is 3, 0. I think it's this because I still have to check my answer. So let's quickly check the answer. We have 8x minus y equals 24. X's are 3's, y's are 0. So 8 times 3 minus 0 equals 24. Is this true? Absolutely. So I need to just check one more. 2x minus y equals 6, where x is 3, y is 0. Is this true? Once again, this is also true. So since it works for both, I can confidently say the solution to the system is indeed 3, 0. Okay, so now what I would like you to do is go ahead and try numbers 7 and 8 on your own. Okay, so hopefully you recognize here in order to eliminate one of the variables by adding straight down, you're going to have to make one of the 8s a negative. So it really doesn't matter which one you change. Just to show you, I'm going to go ahead and change this second one. But what's really important is when you understand that if you're going to change an equation, you must change both sides. You can't just change part of it. That's why I made sure I put the parentheses around the entire equation. So I'm going to go ahead and distribute my -1. So that's going to give me my -4x minus 8y equals a -8. Now that I have this change, I'm just going to go ahead and rewrite this first one underneath it. So I have 5x plus 8y equals 4. Now you're going to notice that the y's are inverses of each other, so they are going to cancel each other out, leaving me with an x equals -4. While that was nice, it kind of just solved it for us right away. Now we're going to take this value and plug it into one of the equations. I'm just going to go with the second one. I think it's a little bit easier, just because the numbers are slightly smaller. 4x plus 8y equals 8. I'm going to go ahead and take this value and plug it in for x. So we're going to have 4 times -4 plus 8y equals 8. Here we're left with -16 plus 8y equals 8. Let's get rid of this constant, leaving me with 8y equals 24. Divide off that coefficient, and y equals 3. Now that I have both, I'm going to say that I think the answer is -4, 3. I can't stress enough, x always comes first, y always comes second. So let's real quick check this answer, where of course x's are -4s, y's are 3. So first I'm going to write down the equation. Now I'm going to go ahead and plug it in. So x's are -4s, y's are 3s. Does it equal 4? Let's see. We have a -20 plus our 24. Does this equal 4? Yes, it does. Now I'm going to check the next equation. 4x plus 8y equals 8. Here the x's are -4s, the y's are 3s, and it's supposed to equal 8. You have a -16 plus 24 equals 8. Is this true? The answer is yes. So again, I can claim that the solution to the system is indeed -4, 3. Now let's quickly check the very last one. Here, you're going to notice that in order to cancel out one of the variables, it's probably going to be a good idea to make one of the x's negative, because right now they're not going to cancel out as is. And just to reiterate again, notice right now the equations are nice because the x's line up, the y's line up, and so do the constants, including the equal sign. So just be on the lookout for that. Right now it's pretty easy, but in the long run it's not always going to look this nice. So I'm going to go ahead and change the first by a -1. So this is going to change it to -3x minus 5y equals a +5. So now I'm just going to rewrite this original one underneath it. 3x plus 8y equals -26. Here the x's successfully cancel each other out because they're inverses of each other, leaving me with 3y equals, let's see, that's going to be -21. Now we're going to divide both sides by 3, and you're left with y equals -7. But of course you're not done. You need to plug it into one of the originals. Definitely feel as though this one might be a little bit easier, so let's use that. It's totally subjective. It's up to you. It really doesn't matter which equation you use. Just putting that out there. So here we have 3x plus 5y equals -5, where I'm going, whoops, let's mention here, I'm going to plug this in for the y. So here we have 3x plus 5 times y, which is a -7, equals a -5. So now we have 3x minus 35 equals -5. Add 35 to both sides, leaving me with 3x equals 30. Divide both sides by 3, and we're left with x equals 10. So now I'm going to say the solution is 10 comma -7. But again, we want to make sure that this is the correct answer, so let's go ahead and check. Friendly reminder that the x's are 10s and the y's are -7. So here, I'm just going to go ahead and plug it in straight to this equation here. 3 times x, which is 10, plus 5 times y, which is -7, equals -5. Here we have 30 minus 35 equals -5. This is true. Now I'm going to plug it into the second one. So here we have 3 times x, which is 10, plus 8 times y, which is -7. It's supposed to equal -26. So we have 30 minus 56 equals -26. This is true. And because it works for both, I can confidently say the solution to this system is indeed 10 comma -7. So hopefully you got the hang of it. You're going to notice elimination's not too bad, but to kind of prepare us for the next lesson for tomorrow, let's practice eliminating terms. So if I were looking at a 3x and an x, what would I have to do to manipulate it so that these terms would eliminate each other? Hopefully you recognize, okay, I'm going to have to change this term here. Since this is a positive 3x, I'm going to have to make this a -3x, so you would multiply it by -3. And here you can test it out. 3x plus -3x is 0, so they are eliminated. It works. What about this one here? What's nice about this one is they're both 5y's, so at least they're the same term. But what we're going to have to do in order for it to eliminate is we're going to have to make one of them negative. So I'm going to go ahead and just change the first one by multiplying it by -1. And you're going to have here -5y plus 5y does, again, eliminate because it equals 0. Okay, so now what if you're given an equation? What are you going to do? So this one's a little bit more tricky, okay? If you take a look, we have a -8x and a -4x. Is there anything that I can do to get them to eliminate? I have a number in mind. Well, let's just really quickly check the y's. This is a 3y and this is a 5y. Is there anything I can multiply to have them eliminate? Yes. However, one method might be a little bit better. Here, I could get this 4 to become an 8 to eliminate it. All I would have to do is first multiply it by 2, but another thing I need to consider is this is negative, this one has to be positive. So I can multiply this entire thing by a -2. Now watch what happens. If you multiply this, you would end up with a positive 8x minus 10y equals a positive 4. So notice here the x's will cancel each other out, which would leave you with just the y's, and you'd be able to solve from there. Now for the fourth one, you're going to look at the x's, the 3x and the 4x. Is there anything you can do to multiply them to eliminate? Yes. What about the 6z and the 2z? Yes. But which one's going to be better? Now, just to backtrack real quick, we did eliminate the x's in the first example, but could we have eliminated the y's? Yes. But what you're going to have to find yourself doing is you're going to have to, first, they're both positive, so you're going to have to make one negative. the only way to make the 3 and the 5s eliminate is to make it 15. So you'd have to multiply this one by 5, and you'd also have to multiply this one by 3, which is not ideal. You don't want to have to change both if you can avoid it. So here you can eliminate the x's, but you're going to have to multiply one of them by a negative. You might, so for example, this could be multiplied by a -4, but this one would have to be multiplied by 3 in order for them to eliminate. So it's going to be a better choice for you to actually eliminate the z's. Why? Because 2 can actually be made into 6 for it to eliminate. We just have to multiply this by a negative to ensure that it eliminates. And you're going to notice here, this would be a -12x minus 6 plus, this by the way should be 18, not 6. Okay, and then you'll notice that the z's cancel each other out, and you'd be able to solve for x's. So just have that ready. We are going to be practicing that a little bit more tomorrow for elimination day number 2. But that is actually going to conclude our lesson for today. Thank you so much for tuning in, and as always, until next time, bye.